Professor Michael Scanlon here. Um, some dogs behind me are going nuts, so I apologize if that bleeds in from the background. Today is Friday, named after the Norse deity Frigg, who is sometimes associated with Venus. So we're talking about Venus's day. And of course, the Romance languages, that day is very closely associated with, the names of that Friday is closely associated with Venus. So let's go ahead and take a look at Venus. Venus is, before we orbit it, Venus is visible at night. It will be visible tonight. And so if I fast forward to about 8:24, pardon, and we look just a little bit north of west, there's going to be a very bright thing that's not a star. That is actually the planet Venus. So let's go ahead and see what Venus looks like. Now, the problem with orbiting Venus is it's completely covered in very, very thick clouds that are mostly sulfuric in nature. So if you want to think about it like this, you can think, they're sulfuric acid clouds. They're incredibly thick. They cover the entire planet, and you have these huge hurricane force winds that blow the clouds across the planet completely in about 5 days. Venus rotates, we say upside down, very, very slowly, and so it takes well over 200 days for it to rotate one time. So for the clouds to go around 5 days, that's pretty amazing. So I've stripped the atmosphere away for this simulation so we can see kind of the surface features of Venus. Now these are all done by radio imaging because the surface of Venus is very inhospitable. One thing I want to point out that we will talk about very briefly when we pop over to the internet is this particular mountain range that is on Ishtar Terra. Now Venus has some quote continents unquote, and they're named after female deities, goddesses of love. Ishtar Terra, Aphrodite Terra, Leda Terra. Most features on Venus are named after women in mythology and history, prominent figures, fictional figures, what have you. There's a Sacagawea mountain, I think it's a volcano. Just different things. You do have some generically named things like Alpha Regio, Beta Regio, but then you have Maxwell Montes. It's the only surface feature that I know of named after a man on Venus that's named after James Clerk Maxwell. So this is a mountain range in the extreme northern hemisphere of Venus. It's a pretty tall mountain. It contains the tallest mountain on Venus as far as I'm aware. Again, Venus is very, or at least it used to be very volcanic. We're seeing some evidence of current volcanism, but it's kind of hard to tell through all the thick clouds. So let's pop over to our site here, and we can see some radio mapped images of Venus, and these are some pretty interesting features. A lot of Venus is, and here's an elevation map. A lot of Venus is covered in basalt, which is a volcanic type rock. This is an ultraviolet image. Venus really isn't purple. And Venus does go through phases. It has a crescent phase and things like that. It has no moons. It does have a very thick carbon dioxide atmosphere. Venus is the hottest planet in the solar system. All right. It's hotter than Mercury. We're talking it gets up to 880 degrees and maybe even more. That's hot enough to melt lead. So Venus is really hot. So here's a 3D model of Venus with the clouds, and that's not very thrilling because it's just so cloud covered. But they do have one that is a radar mapped image down here that if it loads, you can do the same thing. And there we go. If it loads, you can see the same surface features that we saw on our app. Now, Venus is close in size to the Earth. And we'll see that it's a little bit smaller than the Earth. So you see the Earth is just slightly larger than Venus. The Earth is, in fact, the largest terrestrial planet, the largest of the first four planets. Now, we have mapped Venus by radar. Radar can actually make it through the clouds, and that's how we've gotten these images and these terrain pictures. But we do not have the claim to fame as the U.S. to have landed on Venus. That went to the Russians. They landed on Venus a couple of times with their Venera spacecraft, and I think it was the 80s. Here is images from the surface of Venus. We have very, very few of them directly from the surface, and they are from the Venera spacecraft. If you look at the top image, this is actually the picture that it sent. It sent back, and you can see it's kind of hazy yellow, and there's a color correction bar sticking out right there, kind of close to the right end of the picture, close to the bottom. That allowed for the bottom image to be made and color corrected. So, you know, this is the top one is the colors as you see it on Venus, but what would it look like here on Earth? And you see it would be kind of gray and blackish, and that's mostly basalt. That's a volcanic rock because Venus does have, or at least used to have, a lot of volcanism, a lot of volcanoes. Venus has these huge dome-shaped, we'll call them pancake domes or pancake volcanoes. They're really wide, they're really short, type of volcano. Venus's atmosphere is 100 times thicker than ours. Uh, it gets hot enough to melt lead across the entire planet. It's a pretty uniform temperature. It's just really hot. So you have to travel to get to the surface of Venus, travel through these very thick clouds that have pretty much sulfuric acid droplets in them. Then you have to pass through an incredibly thick, dense, hot atmosphere. It is totally inhospitable to life. That's why nobody's bothering to look at Venus for potential colonization. It's just not going to happen. Um, the Venera spacecraft lasted about an hour each before they pretty much shut down and melted. Um, so, yeah, there's no chance of us setting foot on Venus, at least not with any technology we have now. So that's it for today's little celestial object of the day. Go check out Venus, see some more features about this thing. It's absolutely incredible. We're still learning things about it. I highly recommend you dig deeper, as always. Stay safe, everyone. I'll see you tomorrow in the next video.